Next example is here integration of 1 to 5 cube root of 9 minus x divided by cube root of 9 minus x plus cube root of x plus 3 into dx. Now you understand the method to how to evaluate this integration. We put this integration as I is equal to equation number 1, and then by property x replaced here by addition of limit, that is 1 plus 5 minus x, which means 6 minus x. Okay, so we have to replace here x by 6 minus x. Therefore integration I will become I is equal to integration from 1 to 5 cube root of, in numerator 9 minus x, x is replaced by 6 minus x, as we use a bracket here as there is a subtraction. In denominator cube root of, again in first term 9 minus bracket 6 minus x, and plus in last term cube root of x is replaced by 6 minus x, as we put bracket plus x into dx. Now simplifying this only, as algebraic simplification is needed, so we take integration from 1 to 5 cube root of here 9 minus 6 minus plus x divided by, in denominator first term cube root of 9 minus 6 again plus x plus cube root of, this is a simple bracket is vanished to 6 minus x plus x into dx we get. Now we take the simplification. Sorry, in second term x plus 3 is there, so we put here plus 3. So don't make these simple mistakes. If you make mistakes, then the answer will be wrong. Now integration from 1 to 5 cube root of 9 minus 6 is again 3 plus x, in numerator cube root of 3 plus x, in denominator first term will be again 3 root of 3 plus x, and in second term we get cube root of 6 plus 3 9 minus x into dx. Now you can observe this is a we put as integral 2, because in integral first and 2 with same denominator which is interchange only, and now adding equation 1 and 2. See the procedure as we did in first example. Now I plus I we get 2i, and taking limits common we take addition of numerators in equation 1 and equation 2, that is cube root of 9 minus x plus cube root of 3 plus x with same denominator in numerator, which same terms in denominator which is in numerator, that is cube root of 9 minus x plus cube root of 3 plus x. As these terms are same, so they are cancelled, so we get 1 in integral, and integration of 1 is always s with respect to x is x, as the limits are here 1 to 5. By taking subtraction of limit we get value of 2i here as a 4, so I is 2 is the answer. If you understand the method how to solve this example by using property, another thing observe is that the integration is always, as in first integration we get answer 1 by 2, which is a subtraction of limits divided by 2. Also in second term the subtraction of limit is a 5 minus 1 is a 4, and answer is a 4 by 2 is a 2. Similarly you can evaluate the remaining answers of integral, as this integration has a limit 1 to 4, so subtraction of limit is a 3, and the answer of or integration of this integration will be 3 by 2, and remaining. As we take the next example, as I is equal to integration from 0 to 7 cube root of x divided by cube root of 7 minus x plus cube root of x into dx. Now I put this as a number 1. Now by property x replaced here by, actually lower limit is a 0, so addition of limit is a 7 only minus x. Now x is replaced by 7 minus x in integral, so we get I is equal to integration from 0 to 7 cube root of, in first term numerator root of 7 minus x, in denominator cube root of 7 minus x is replaced by root of it's 7 minus x plus cube root of x is replaced by 7 minus x into dx. As we have to only simplify this term in denominator, so his numerator remain as it is, cube root of 7 minus x. In denominator you can observe as a minus sign get in bracket, plus 7 get minus 1, 7 minus 7 get cancelled, and minus minus there will remain only plus x, as last term is a cube root of 7 minus x into dx. Now put this as a number 2 as algebraic simplification is completed. Now by procedure we add equation 1 and 2. On right hand side we always get 2i. On left hand side we take addition of limits with same limit, addition of integration having same limits. So we take common limit from here 0 to 7 and only add the fractions in denominator which have the same denominator. So we add only numerators of first equation, that is cube root of x, plus denominator of second numerator 7 minus x, which terms are in denominator also. So in denominator we get cube root of x plus cube root of 7 minus x into dx. Now equal numerator and denominator there, so we cancel them. We get in integration only 1, as integration of 1 is always x with limits at 0 to 7, as we get 2i is a subtraction of limits, that is here 7. Now I is always subtraction of limit divided by 2, as here is a 7 by 2. So answer is a 7 by 2. And final example has a limit from 0 to a, as a subtraction of limit is a, so answer will be a by 2, which you can. The method of integrations by using property, as we learn, the same method is follow in these examples also. As you can observe here, these example contain trigonometric terms, so we have to make trigonometric simplification as we did algebraic simplification in last part. Now here we take this integration as I and put it as in number 1. Now by property the x replaced here by addition of limit. Actually addition of limit 0 plus pi by 2 is a pi by 2 minus x. So I is equal to integration from, as limit does not change from 0 to pi by 2, we only replace values of x by pi by 2 minus x in integral. So in numerator we get integration of sine of pi by 2 minus x divided by root of, in denominator also we take root of sine of pi by 2 minus x, plus in second term in denominator root of cos of pi by 2 minus x as multiplied by this. Now here we take algebraic simplification. Actually algebraic simplification is nothing but to use formulas of algebra. As you can observe here, the angle is in form of pi by 2 minus x, which is a allied angle S, as this is the angle of first quadrant. So we know the trigonometric ratio of this angle is as sine ratio is changed to in cos ratio with its allied angle x. So this is a cos of x, as this is in first quadrant, so value is positive. So remember the formula, sine pi by 2 minus x is equal to cos of x. Similarly, you know cos of pi by 2 minus x is given, then its value is a sine of x. So using these formulas we can simplify this integration, or we make trigonometric simplifications here. So now integration from 0 to pi by 2, root of sine pi by 2 minus x is a cos of x in numerator. In denominator, in first term root of we get cos of x, and plus as cos pi by 2 minus x is a sine of x, so root of sine of x is a we get. So we put it as number 2 as we did algebraic trigonometric simplification. Now adding equation 1 and 2. Now adding 1 and 2 we get on left hand side 2i, and on right hand side, as limits of both integral is same, so we take common limit and take only addition of fractions containing integral. As both fractions has a common denominator, so we take addition of numerator. In first integral we have in numerator root of sine x, plus in second root of cos x, and the denominator is equal to numerator, so we put root of sine of x plus root of cos of x in denominator. As both numerator and denominator are equal, so get cancelled and we get 1 in integral. The integration of 1 is always x with limit, as here 0 to pi by 2. As x is in bracket, so we take only subtraction of limits pi by 2 minus 0, which is a value of 2i. So 2i is equal to pi by 2, so I is equal to pi by 4, which is our answer. As you understand, the limits are 0 to pi by 2, so the subtraction of limit is pi by 2 divided by 2, that means pi by 4 is the answer. So the same process and same method is used to evaluate this example, but using trigonometric simplification.